Welcome back to Math 103. This is video number 10 on apportionment. At the end of the last video, we saw the general pattern for interpreting what standard divisor means concretely in each of these various examples from real life. So standard divisor, in the context of allocating buses to bus routes based on riders, meant average number of riders per bus. Similarly, in the context of apportioning nurses to hospital shifts based on patients, standard divisor equals the average number of patients per nurse, the average number of incidents per police officer, the average number of enrolled students per faculty position, the average number of minutes spent on homework per candy bar, the average number of items sold per sales staff member, the average number of users at a computer center, the average number of users per computer. Okay? So it's always population per seat. All this is very nice, but how does it help us with the apportionment problem? It helps in two ways. One is that it's going to lead us to other ways of solving the apportionment problem, other methods that have actually been used in American history besides Hamilton's method. Before we get there, it gives us another way to think about each state's proportional share of the seats based on population. This is what we called standard quota before, right? And we had a certain way of thinking about this. We thought about what share of the total population does each state have, and if, for example, Massachusetts has 45% of the total population, then it is in some sense entitled to 45% of the seats. Now, here's a new way of thinking about it. Key image. The standard divisor as cookie cutter, as population cookie cutter. Now consider how many times a cookie cutter, an ordinary cookie cutter that you're used to, of a certain size, goes into a certain amount of dough. So you stamp out a cookie right there, you stamp out another cookie, you stamp out another cookie. At the end of the day, the amount of dough you had enabled you to stamp out a certain number of cookies of the same size. Now think of the standard divisor, in our context, as the population cookie cutter, right? So the standard divisor equals the average district population, and we're going to take a population map of each state, and within it we're going to stamp out a certain number of districts. Each one is going to have the same population, the same way a cookie has the same amount of dough. Based on using this standard-sized population for each district, we're going to ask, how many districts can we carve out of each state? Just to illustrate, let's look at an actual population map of New England and see how this might work in practice. We said in the most recent version of our example that Maine would have 2 districts, so we could carve out one district that looks something like that, and then you would have the other district up here, where the population is much more sparse. So these would be the 2 districts within Maine. In fact, these pretty much are the 2 districts in Maine in real life, where you have a greater population density here along the coast and within reasonable travel time of Boston, and you have a vast region here which is geographically large, but equivalent in population to this coastal strip along here. Similarly, within Massachusetts, you've got a district maybe out here in western Massachusetts. You have another district that includes Cape Cod. You will have some tiny districts geographically that have the same population as the other districts that are in and around Boston. You'll have a medium-sized district north of Boston, etc. So each of these districts, each of these congressional districts within each state has the same population as the other district within the state, exactly the same population. From one state to the next, they won't be exactly the same, but they should be not too far away from one another. And within each state, you'll see that some of these districts are geographically larger than others, but equivalent in population. All this is very useful for giving us a new perspective on standard quotas. So we've already seen the idea that the standard quota, which is a state's exact proportional share of seats based on population, that it can be computed as the state's fraction of total population times the total number of seats. right? So if Massachusetts has, say, 45% of the total population, 45% of the total number of seats tells you how many seats Massachusetts is exactly entitled to based on population. But there's another very useful definition now. The standard quota of a state equals state population divided by standard divisor. This makes sense in terms of what we were just doing on a population map. We were looking at a state, a single state, and asking how many times does the standard divisor cookie cutter go into that state, the population map of that state, right? So how many times does the standard divisor go into the state population? That's the same as state population divided by the standard divisor. So the standard quota of Massachusetts equals the precise number of standard-sized congressional districts which can fit into the population of Massachusetts, allowing a decimal part. Alright, so now we have two different ways of computing standard quota. Let's make sure they agree. So before you go on to the next video, answer the following question. Check whether the two definitions of standard quota actually give us the same number by computing the standard quota of Massachusetts using the new definition and seeing if it equals the same number we obtained using the old definition. What I have in mind here is that we're going back to our original version of this example, where Massachusetts had 6.3 million people out of 13.9 million people total, and there were 25 seats. And so what did we do? The original definition was to take Massachusetts' share of total population and find what is that corresponding share of 25 seats. The answer was 11.33 seats. So the task now is to see whether the new definition of state population, 6.3 million, divided by standard divisor, really equals the same 11.33 seats.